Your first student experiment that you're going to do in biology is the yeast fermentation experiment, which is a measure of respiration in yeast, but it's fermentation because it does it without oxygen in this case, and it makes alcohol as a byproduct. So for fermentation, before you do anything else, you've just got to actually wake up the yeast and get them respiring and actually ingesting sugar and using it to metabolize and recharge their batteries, essentially. Because when you get given the yeast initially, these guys here, they're actually inactive because they've actually been freeze-dried. They're actually in an inactive form. Essentially, they're in hibernation, and you need to wake them up and get them to actually start living again. So we do this by giving them a nice warm place to be happy and giving them some food to eat. So you need to get a conical flask like this, put in about 200 ml of warm, lukewarm water, add to that 1 teaspoon of yeast and 2 teaspoons of sugar. Now mix that up and leave it for about 10 to 15 minutes at first while you get other things ready, just to give the yeast a chance to warm up, to become active again, to start eating the sugar and get respiring. And you'll know when they're ready because you'll see froth being produced, which is a byproduct of catching the carbon dioxide that they're releasing as they respire. So now you have to set up several trials in order to measure just the rate of respiration. You're not changing anything yet, you're just figuring out how to measure it. Now, when it comes to any type of respiration, it's a chemical reaction and it has reactants and products. And to measure the rate of a reaction, all you have to do is either measure how quickly the reactants go down or how quickly the products are produced. And in this case, we're going to be measuring the products. We're going to be measuring the production of CO2 gas in the form of bubbles. So this is how we do it. First of all, you're going to be given these 3 ml pipettes. You take those pipettes and you fill them with your starting mixture, the yeast mixture there, right up to the top. And you weight them down with these little washers here. You take each one of these pipettes, you'll have to fill as many as you can for your trial, and place them in a large test tube all the way down to the bottom. They should go straight down because of the washers that you got there. And then once they're in there, you actually fill that test tube with more of the same warm water that you used to make your starting mixture, because you still need to give them a nice warm environment in which to actually survive, be happy, thrive. Okay, so you have to fill that with warm water. Now at first, this may go a little cloudy if you have a lot of mixture on the outside of your pipette. If that's the case, put your finger over the top of the pipette, tip the dirty water out, right it, and refill it, and so that you have reasonably clear water covering the pipette. Now all you have to do is literally count the bubbles. So you're going to be having quite short bursts of this experiment. You only have to count the bubbles for about 2 minutes, and you'll have enough data there to get an accurate idea of how quickly they're respiring. You don't want to leave it too long because as this water cools down, it will actually affect the rate. So you only want to collect data over short amounts of time where the temperature is reasonably the same. You do that over many trials, and I wanted you to see if you're getting roughly the same answer for all of your pipettes, because they've come from the same mixture. Hopefully you've made and set them up exactly the same way, so you should be getting roughly the same respiration rate or bubble count in all of your measures. This is what it looks like. Now, yellow maybe wasn't the best background I could have picked here, but it works. Here you can see that there's no bubbles here, and as you go along here you can see a bubble starting to come out, and then last but not least there's a bubble forming at the very top there of my pipette. So essentially that is how you actually measure respiration using this technique. Then it's up to you to actually vary one variable to see how much it changes that respiration rate. So that's your starting point. I'll let you go from there. Good luck.